Alright, so today, 7.3, we're going to talk about binomial radical expressions. And binomial radical expressions are considering like radicals. Okay, and they are radical expressions that have the same index. We've defined these before, but in case you don't remember, that's degree of root and the same radicand. And that's the number under the root sign. I'll put x root sign. Okay. So really what this section really is just combining like terms. Pretty easy. Okay. We're going to probably get through all of this and then your homework and then probably even start the next section on Monday or on the first day of this lesson. Okay, so when I look at a problem like number 1, they have a 3 as their index. They have only an x underneath. So really, this is really just 5x minus 3x, which would be 2x. So this is just 2, and that is my x. I can rewrite it as cube root of x. 5 apples minus 3 apples is 2 apples. It's the same kind of thing. Okay. Again, they share the same here, so I can just add outside and get 9 square root of 2. So again, I got 4 of them here. I got 5 of them here, so total I have 9 of them, and of them just gets replaced with square root of 2. Okay? You guys try 3, 4, and 5. Go ahead and press pause. Try 3, 4, and 5. On number 3, again, they're like radicals, so I can add them, and they're like radicals, so they have the same index and the same radicand. These are like radicals as well. I have 4 of these, and I have 5 of these. Gives me 9 of those. Now this one on the other hand is probably going to get some of you because they do have the same radicand, but they do not have the same index. And when that happens, you're just going to rewrite it because you cannot combine them. Again, this would be like if I said 4th root of 5 is x and 3rd root of 5 is y, 7x minus 2y. Again, if I replace that with apples and bananas, you can't say 7 apples minus 2 bananas doesn't give you 5 banana apples, or whatever you want. It's just what you see. Okay. Now, we can do them. Don't give up on a problem if they don't have the same radicand. If they have the same index, we might be able to rewrite them all in terms of something we can combine. Like, for instance, this is 6, that's 9 and 2. So square root of 9, square root of 2. This is 4 times, this is 4 and 2, so square root of 4, square root of 2, minus 3 times, this is, well, 36 and 2. Yes, it's 9 and 8, but remember, if it's 9 and 8, I can keep that going to 4 and 2, and it just gets a lot messier. Can I do it? 3 times 2 is 6, square root of 2. That's going to be the same thing as, of course, when I get to the bottom of that problem. So I'm breaking them all down here. This is, of course, 6 times 3, square root of 2, plus 4 times 2, square root of 2, minus 3 times 6 square root of 2, 18 square root of 2 plus 8 square root of 2 minus 18 square root of 2. Hopefully you can see that that is just 8 square root of 2. Now that they have the same radicand and the same index, I can add them together. They are like radicals. Now one thing I will tell you is that this would just cancel out with this. That's how I got that answer. But if you can't see that, this is 26 of them minus 18 of them gets me back to 8. Okay. Try number 7. Set up very similarly. Try number 7, please. So 5 of them plus 12 of them minus 15 is 17 minus 15 is 2 square root of 2. Okay. It's as simple as that. Don't make it harder than it is. Now when we want to multiply binomial radical expressions, this is really just foiling them out. So first, I've got 3 times 2, which is 6. Outside, I get 3 times 4 square roots of 5. If you remember, you can only multiply what's outside by what's outside and inside with inside. So this is just simply 12 square roots of 5. Okay? And another way to think about it is 4x. If I've got 4x, 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 that equals 12x. Plus inside. So the inside, again, outside with outside, 4 square roots of 5, plus last, and I've got outside with outside, inside with inside. I know what that is. We'll get to that. and that's generally going to happen in these problems. So I can combine like terms here. I've got 6 plus 16 square roots of 5 plus, well, this becomes 8 times, of course, 5, which of course is 40. When I add to the 6, I get 46 plus 16 square roots of 5. And it is properly written in the form of a plus b square roots of x. And that is the proper way to write it. You guys go ahead and try number 9. I'll give you a hint. Squared means you're timesing it by itself, so I can get rid of that and just rewrite it again and go ahead and FOIL it through. Remember, when you're foiling, you should be able to make a nice little happy face out of it. Hee hee. Okay, FOIL it up. Okay, so here I've got, this is obviously 2, this is obviously 3. Right here I've got negative 1 square roots of x and negative 1 square roots of x, which is negative 2 square roots of x, square roots of 6 in this case. Combine your like terms, that is a plus 3, so I shouldn't go 2 minus 3, the minus is attached here. 2 plus 3 is 5, minus 2 square roots of 6. Okay? Alright, number 10, FOIL, but when they are, this is called conjugates, when they are conjugates, we've kind of talked about this before, but very briefly. We're going to get just a squared minus b squared. So what do I mean by that? A is 2. B is square root of 3. Well, what is a squared minus b squared? 4 minus 3 is 1. Well, let's FOIL it out and check it out. 4, I get a minus 2 square roots of 3 and a plus 2 square roots of 3, which of course are going to cancel each other out. And then last I get minus square root of 9. So I get 4 minus 3, which is 1. So you can FOIL out any of these, but if you can remember when they're conjugates. And what does conjugate mean? Conjugate means just it'll be the exact same thing, just one's plus and one's minus in your two binomials. Okay? The answer to these will always be a whole number. Okay? So, you guys try this one, press pause, go ahead and try the next one out. So I get 3 as my answer, which of course I do, because if I again plug it in here, I'd have a squared minus b squared, which is square root of 5 times square root of 5. Otherwise, these cancel 5. These cancel 2. And I end up getting 3 either way. Okay? That's it. That's 7-3. Super fast one. Your homework is the next 2 pages. 1 through 24. I'm actually going to take a few problems off. So make sure you pay attention to Google Classroom to see what that is. Have a good day.